All right, students, we're here with triangle congruence proofs phase 2. So we talked about 3 popular things from yesterday to help us with our congruence proofs: reflexive, vertical angles, and then midpoints. All right, we're going to talk about more popular things that's going to help us. And for whatever reason, this first one, I find that students like to struggle with this one. Not really sure why, because I always do a really good job of explaining it. But nonetheless, so let me try to think of a good picture to draw. Let's draw this picture right here. All right, we got that picture. Then let's do this. All right. Now let's call this triangle love, because we love math class. All right. Now it might say something like this. Now this students struggle with this. LE bisects angle OEV. All right. So realize that the definition of angle bisector results in 2 angles being congruent. Angles. Students always go to sides for some reason. Nope, an angle bisector creates 2 congruent angles. All right. So if we have this sentence right here, LE bisects OEV, that's saying that this segment bisects this angle. So that's going to force that angle and that angle to be congruent. So that means OEL is congruent to angle VEL. All right. So OEL is congruent to VEL. All right, so be careful with angle bisector. Again, in years past, students struggle with it. Why? Just I guess you gotta struggle with something. All right, so we got this quirky picture right here. Look at this. AC bisects angle BAD. Angle B is congruent to angle D. So let's just dive in. All right, before I even draw my picture, I just feel like writing out my given information. Awkward silence right now. Okay, so, and then I'll easily, angle B and angle D are congruent. Now let's focus on this part right here. AC bisects angle BAD. All right, so this ray is bisecting angle BAD. So that's going to force this left angle and this right angle to be congruent. So angle BAC is congruent to angle DAC. All right, definition of angle bisector. So it's essentially just the same thing as midpoint, but midpoint's for segments. Angle bisector is for angles. All right, so that's that right there. So now I clearly have 2 angles that are congruent. Now something from yesterday, something we're going to see a lot, is that this shared side, AC, is congruent to itself. You have to know that by looking at the picture. All right, AC is congruent to AC, reflexive property. All right. So now looking at this, what do I got going on here? I have an angle, I have an angle, I have a side that's non-included. All right, this side only touches one angle. It does not touch the other one. All right, it only touches one of them. So it's going to be triangle ABC is congruent to triangle ADC by angle side. All right, that's it right there. All right, so that's angle bisector. Now we got right angles are congruent. Again, you might see this. You might not. Let me think about how I want to draw this picture. Let's draw. I had a brain fart. I had a writer's block right there for a second. We'll draw it like this. All right. We'll call this triangle neat because triangles are really neat. All right. So it might say something like this. Well, it's saying that NEA is right angle. You might say AET is right angle. Thus, these two angles must be congruent because all right angles are congruent. All right, and that's a theorem. We actually proved this back all the way in Unit 2. But nonetheless, there we go. All right, so let's dive into this proof right here. Given, all we're given, technically I should just give you guys more information. Let me modify this just slightly. LM is congruent to MJ. All right. So let's knock this out of the park. Just write this right here. Given. All right. And then this right here. So perpendicular. LJ is perpendicular to KM. So it's already kind of marked right here. These are perpendicular. So that's a right angle and that's a right angle. All right. So I can say that angle LKM is let me write it like this. LKM and angle MKJ are right angles. Why? It's just a definition of perpendicular lines. When it's telling me I have perpendicular lines, I'm going to have right angles. Okay. Thus, there's a couple different things I could say here, just depending on the teacher, whoever's constructing the quiz or a test, whatever it may be. Some people will specifically say then, well, that these two angles are congruent by right angle congruence theorem, RACT, right angle congruence theorem. And then you might even see this step right here where it's specifically saying that the triangles are right triangles. Just depends on which teacher wants to take which path. By definition of right triangles. All right. So a lot of writing going on. I'll pause there for a little bit as you kind of catch up. A lot of dense things, but nonetheless, we are getting kind of close to being done. Because from here, what I can say is, well, this shared side. Again, we're seeing our good friend, the reflexive property, again. All right, this shared side's congruent, reflexive property. And then that these two triangles now are congruent. Why? They're right triangles. We have a hypotenuse, we have a leg. So I can say, bloop, LKM is congruent to triangle JKM by hypotenuse leg. All right, that one was a little lengthy, but stay tuned.